A little bit of math can accomplish what all the girls and Bob White are. A little bit of math can keep a secret. Hello everyone, my name is Abhilash Rana. Today I'm going to present my topic Guide to Cryptography Mathematics. Well, mathematics play a vital role in cryptography. Cryptography is the science of using mathematics to hide data behind encryption. Cryptanalysis, it's important to understand the mathematics side of encrypting and decrypting data, the type of algorithm it follows, which mathematical tools and pattern it involve. It is basically look for the weakness who attack the system. In this, we will explore every part of mathematics behind cryptography and different methods used to encrypt data with latest algorithms. Here we begin. History of cryptography mathematics. The cryptography is derived from the Greek words cryptos, hidden. There was many theory proposed. First was the documented use of cryptography circa 900 in 1900 before Christ. There was Indian theory of monolithic substitution cipher, which was discovered in 400 BC in India. The art of writing in cipher, documented as Kama Sutra, in which lovers reciprocating love to each other. Colonial wants to convey some military plan to Lieutenant Colonel. There was a big revolution during World War One, and second there was invention of Zimmermann telegraph. As you can see over here, World War Two it was famous for cipher breaking. There was invention of Enigma machine, which is used by German military Nazi force in the World War. We have how pure mathematics can have unexpected application. Mathematics consists of pure and applied. Pure mathematics does not involve any application outside of mathematics. The examples number theory, algebra, real analysis. We have applied mathematics, which is used in application of like biomedical engineering, physics, chemistry. We have example differential equation, numerical analysis. Here you can see the figure. Number theory is a subset of pure mathematics, and over here it acts as applied mathematics. It's a study of integer and integer valued function, like modulus function, greatest integer function, signum function. It's just properties of natural number one, two, three, counting numbers, a queen of mathematics. Still, great mathematics devoted study to their properties, and they are just one, two, three counting numbers. So that's weird. What could be more simple than the natural number one, two, three? Well, you are right. They have some mind-boggling properties which we're gonna study in further slides. We have importance and concepts of number theory in cryptography. Number theory plays an important role in encryption algorithm, where important concepts are prime number divisors, greatest common divisors, congruency, Euler-Fee function, Euclidean algorithm, which is very important. For this, we suppose a and b as integers, and we have condition they not be non, they not be zero. Then there exist integers x and y such that GCD of AB can be written as a combination of x and y, which is linear combination. Integer modulo function Zn. Zn is cyclic group if and only if n is prime. Here we get the cyclic group Zp cross of order P, which is generated by its generator G. Here you can see. Fermat-Little theorem. Well, it is a special case of Euler theorem. If we take over here n is equal to p, then Pn can be written as p minus 1. Fermat-Little theorem states that if p is a prime number, then for any integer a, the number ap minus a is an integer multiple of p. Here we get ap minus 1 congruent to 1 mod p. If we multiply this equation by a, we get ap congruent to a mod p. So how do large prime number help in ensuring computer security? This is a question. Application is an important development in RS algorithm. We'll see in our next slides. Mathematical algorithm in cryptography. We have integer factorization problem, discrete logarithm problem, Diffie-Hellman problem. This is very important. P be a prime number, G be a generator of cyclic group ZP. GA mod P is a public key of Alice, GV mod P is a public key of Bob, A and B are the private key of Alice and Bob respectively. Our motive is to find GAB mod P. Alice will compute this, Bob will compute this. Here we see every drop is standing, could not able to fetch the information. We have limitation of Diffie-Hellman. It is secure against passive dropper, but not against man-in-middle attack. Is because of the mathematics. The parameter we use PG because G generate a small subgroup. So brute force is prevalent. We can improve it by increasing the parameter. If we can give it a large cyclic subgroup order of GP minus 1. G is a generator subgroup order Q mod P and parameter are PQG. We increase the parameter and this is an improvement of DHP. Further moving, RSA is important. It consists of key generation, encryption, decryption. Key generation, for this we need to choose large prime number. Then we have to apply integer factorization problem. Then we need to choose E such that the GCD is 1. Then we need to calculate D such that ED is congruent to 1 mod phi n. Here we use Euclidean algorithm. If we take A is equal to E, B is equal to phi n, then X will be an extended Euclidean algorithm. We get public key, private key. Like here, B wants to send a message M to A. He will send C ME mod N public key. Then after receiving message, after receiving C, A will retrieve message back as M dash is congruent to CD mod N. Then we have M dash congruent to MED mod N using A's private key. It will able to retrieve the original plain text. We use this ED congruent to 1 mod and phi n, and using number theory concept we get this M dash congruent to M mod n. Moving further, RSA cracking. It's an argument topic. Look at key. If somebody shows IFP decryption key can easily be tested. Does RA provide less than 99.8% security? Well, it's the mathematics involved in this. Why is that problem? It's because of the mathematics involved in this. Because it is easier to find the GCD of two number than to factor it. So, and finding GCD is time proportional to the number of digits. When we get the common divisor, you can read the message sent by any of the public keys. So there are researches going on. They are able to crack these number pairs of public key. Does RSA cracked? What do you think? Not quite just vulnerable. It is prone to factoring attack. RSA public key, if we take factor modular and modulus n, then attacker can find phi n. So for this purpose, we must use strong large prime numbers. This is my answer to my question which I asked you previously. So and also computing GCD between 36 trillion keypads is a laborious task. It will take years, not hours. Then we have the conclusion. We discuss various number theory concepts, how pure mathematics turns to be serendipity, different algorithms, and the algorithms found to be complex and unique, the keys, the role of keys. Node theory is a current mathematics working area to develop a public key cryptography that is immune to quantum airdrop. It's amazing. This is how mathematical science play a crucial role in cryptography. We have references. I use importance of number theory and cryptography to explain the base concept of number theory. I use privacy Canada as my main heading topic. I use an overview of cryptography to explain the history. I use its still safe to use RSA encryption for cracking RSA. I use public key cryptography using discrete logarithm to explain Diffie-Hellman problem, integer factorization problem. I use cryptography and number theory. I use what is RSA encryption and how does it work to explain my RSA. Thank you. Have a good day. I hope you like my slides. Thank you.